Okay, welcome to chapter 15.1. This is where we're going to talk about energy and its different forms. So energy is kind of hard to explain what it is or describe what it is, but in science terms, it's defined as the ability to do work. That doesn't mean that energy goes to work every day. What it means is it is the ability for a force to be applied to move an object some distance. So if I push a stapler across my desk, I am applying a force to it to move it some distance. We can say I am doing work on that stapler. So what that means is work is a transfer of energy. Anytime we apply a force to something to move it some distance, we are transferring some type of energy to that object. Now, there are many different kinds of energy, and all of them are able to do work. There's kinetic energy, gravitational potential energy, elastic potential energy, thermal energy, chemical energy, electrical energy, electromagnetic energy, and nuclear energy. Now, the first three are all considered mechanical energies, and this is because they have to do with the movement or position of objects relative to their surroundings. All of the other types of energies can fit into either kinetic or potential categories, depending on what causes these kinds of energies. But these, the mechanical energies and thermal, chemical, electrical, electromagnetic, and nuclear are what are considered the major forms of energy. So kinetic energy is the energy of motion, and it depends on the speed of an object, and I didn't mean to write velocity here, I meant to write mass. So it depends on the speed of an object and the mass of an object. The faster it's going, the more kinetic energy it will have, and the larger or more massive it is, the more kinetic energy it will have. The symbol for kinetic energy is just Ke, and the units are joules. So all forms of energy and work are measured in joules. Kinetic energy itself has an equation, and that is Ke is equal to 1/2 times the mass times the velocity squared of an object. And it's very important that it's velocity squared, not the whole thing squared. So when you're doing a kinetic energy problem, you have to make sure that you square the velocity before you multiply by the mass and multiply by 1/2. If you multiply 1/2 times m times v and then square the whole thing, it's going to give you a very different answer. The next type is gravitational potential energy. And potential energy in general is just stored energy. It's energy that is stored in an object so that it can do work later on. But gravitational potential energy is energy that's stored that depends on an object's height. And this depends on not only the height of the object, but also its mass. So its symbol is Pe little g, so potential energy gravitational, and the units are joules. And the equation for gravitational potential energy is mass times the acceleration due to gravity times height. And remember, on Earth, the acceleration due to gravity is always going to be 9.8 meters per second squared. So what this equation is telling us is the higher I raise an object, the more gravitational potential energy it will have, and the more work it will be able to do later on when it interacts with another object. Another common type of potential energy is elastic potential energy. So elastic potential energy is energy of an object that is either stretched or compressed, like a spring. And it depends on how much it's deformed and how stiff the material is. So if you have a spring and you stretch it a little bit, it's not going to have a lot of elastic potential energy. But if you stretch it a lot and deform it more, it will have more potential energy. And the stiffer the spring is, meaning the harder it is to deform, the more elastic potential energy it will have once it actually is deformed. The symbol is Pe little e, potential energy elastic, and its units are joules. And this energy does have an equation, but we're not going to learn about it in this class. The next type is not a mechanical energy. So elastic potential energy, gravitational potential energy, and kinetic energy are all considered mechanical energies. Moving away from the mechanical energies, we start talking about things like thermal energy. So thermal energy, as it sounds, is heat energy. The hotter an object is, the more thermal energy it has. And this depends on how fast the atoms are moving within that material. So thermal energy is a type of kinetic energy. The faster the molecules and atoms inside of a substance are moving, the more kinetic energy they have, which means the hotter the object will be and the more thermal energy it will have. So lava is a great example of thermal energy. The atoms in the lava are moving very, very, very fast, and they have a lot of kinetic energy. The symbol for thermal energy is TE, and the units are joules. The next main type of energy is chemical energy, and this is something we interact with every day. So chemical energy is energy that is stored in chemical bonds. And this depends on how much energy is stored within the substance, or how much potential energy is stored within those chemical bonds. As we learned in our chemistry units, some atoms like to be bound to one another, and they store a lot of chemical energy between them. And some atoms don't like being bound together, and they don't store very much chemical energy between them, and they're easy to break up. So it really depends on what atoms and molecules we have bonded to each other. The symbol is CE for chemical energy, and the units are joules. And we interact with chemical energy every day because we eat food. So within the food we eat, there is energy stored in those chemical bonds. And as we digest that food and break those bonds, we can harness that energy and then use it ourselves. The next kind of energy is electrical energy. And this is the energy of electrical charges, either positive or negative. And electrical energy depends on how charged the object is, or how much potential energy it has stored within those charges, and how fast the charges are moving, which is a form of kinetic energy. The symbol for electrical energy is EE, and the units are joules. And electrical energy is what we take advantage of every day when we turn on our computers, our phones, turn the lights on. All of those kinds of things run on electrical energy. Very closely related to that is electromagnetic energy. So electromagnetic energy is energy in the form of waves. And these are things like light and X-rays, or as you can see here, microwaves. These sources, or these types of energy, depend on the temperature of the source. So the hotter the source, the higher energy electromagnetic waves will be given off. A microwave doesn't have that much energy in it. It turns out it doesn't have to get very hot before it produces microwaves. The sun is very hot. Remember, it's about 15 million degrees on the surface of the sun. And because it's so hot, it lets off electromagnetic waves that have much higher energy, like visible light and X-rays. The symbol for this is also EE because electromagnetic energy and electric energy are very, very closely related. So we can use the two symbols interchangeably. And again, it's measured in joules. And the final major type of energy is nuclear energy. So nuclear energy is the energy stored in atomic nuclei. So where the protons and the neutrons are found in the nucleus, there is energy stored within that nucleus. And once you start taking it apart or adding more things to it, we can release that energy. And the amount of nuclear energy in an object depends on the stability of the nucleus. So we talked about this a little bit when we did our nuclear power debate, but some elements are not very stable. And that's because they tend to fall apart. They can't hold themselves together because they're so large. So the less stable a nucleus is, the more nuclear energy will be released. The symbol for this is Ne, and the units are joules. So now that we know about the major types of energy, answer these questions on page 452 and have it ready for tomorrow.